Hi, in this tutorial I will give an overview of how you can use a DAQ device in Visual Studio and in C#. I will exemplify it by using a DAQ hardware and the DAQmx driver software from NI. NI is previously known as National Instruments. So basically the purpose is to read and write data using a DAQ device. We are going to use Visual Studio and the C# programming language. We will exemplify it by using a DAQ device from NI, previously known as National Instruments. And in this tutorial we will use a DAQ device called USB 6008. This is a DAQ device from the USB 6000X low-cost series. So we have USB 6001, 6002, 3, 4, etc. These USB or these DAQ devices from NI use the so-called NI-DAQmx driver. So this is a driver software that you can download and install for free. And examples shown here will work on all DAQ devices from NI that are using this DAQmx driver. And that's quite many. I guess there are hundreds of different DAQ devices that are supporting and using this DAQmx driver. The principles used in this tutorial can also be applied on other DAQ hardware from other vendors. So let's start with a short introduction to DAQ or data acquisition. So here you see an overview of the basic principles regarding data acquisition, or shortened DAQ. So a DAQ system consists of 4 parts. Part number 1 here is the physical input-output signals. You could have different types of sensors. You could have output devices like valves, pumps, etc. So that's the first part. You need to have some physical input-output signals. And then next you need to have a data acquisition hardware like this USB 6008 or similar devices. Next you need to have number 3, driver software, and in this case we will use this NI-DAQmx driver software from NI. And fourth, you need to create or make a software or an application that fulfills your purpose. So basically this software will then use the DAQ driver in order to connect to the DAQ hardware and again read or output data from these sensors or other types of signals. So basically a DAQ device can be used to read data from different types of sensors. It could be temperature sensors, etc. And this is typically an analog input signal. Or we can use a DAQ device to control something, and then we typically use analog or digital output. And this could be a heater, it could be a pump, valve, it could be a light with a dimmer, etc. And typically a DAQ device has both digital and analog channels. So most DAQ devices has 4 different types of signals. You have analog output signals, you have analog input signals, you have digital output signals, and you have digital input signals. And then analog channels typically have values between 0 and 5 voltage, or 0 to 10 voltage, or minus 10 to 10 voltage. It also could have typically 4 to 10 milliampere, etc. Or 4 to 20 milliampere. While the digital channels they are either 0 or false, or typically around 0 voltage, or they can be 1 or true, and then the voltage value is typically between 2 and 5 voltage. So these are the basics regarding the DAQ devices. So next, let's introduce DAQ devices from NI, or previously known as National Instruments. So here you see the DAQ device that are used in this tutorial. This is a USB 6008 DAQ device. It has analog inputs, which is on here on the left side, and it has analog outputs, and it has digital inputs and outputs on the right side. Today USB 6008 has been replaced with newer versions like the USB 6000, 6001, 6002 and 6003. These newer devices has the same or similar functionality as the USB 6008 that I'm using in this tutorial, and since the functionality is the same, you can use any of these devices or also other USB devices from National Instruments in this tutorial. And for all these devices you need to use this NI-DAQmx driver software in order to be able to communicate and control the DAQ devices. And this NI-DAQmx driver software can be used in combination with LabVIEW, Visual Studio and C#, Python, MATLAB, etc. In this tutorial we will use Visual Studio and C#. And this driver NI-DAQmx can be downloaded for free, but of course you need to have or buy a NI-DAQmx compatible DAQ device in order to follow this tutorial. So make sure that during the installation of this NI-DAQmx software you need to make sure that NI-DAQmx support for .NET Framework 4.5 or larger is selected. If not, you cannot use it in Visual Studio and in C#. Next, I will introduce a software called Measurement and Automation Explorer, shortened MAX. So MAX is an application that are automatically installed when you install the NI-DAQmx driver software. And with this software, this MAX software, you can configure your NI hardware. So typically you can change the name of the device, you can test it to make sure that the device is working properly before you use it in this case in Visual Studio and in C#. Here you see an image of this Measurement and Automation Explorer. So here on the left side under Devices and Interfaces, then you plug in your DAQ device, your USB DAQ device in your computer. It will pop up here, and as you see here I have connected an NI USB 6008 DAQ device into my computer, and then by default it gets the name dev1, but you can change it here. You can also click self-test, and you can use the test panels, etc. in order to make sure that this device is working as expected. And also, if you don't have a real USB 6008 DAQ device or similar, you can also set up a simulated device. You also do that from the MAX software. So you just right click here on the Devices and Interfaces, and then you select Simulated NI-DAQmx device and or modular instrument, and then this window will pop up where you can select the device that you want to simulate. So in my case I select NI USB 6008, and then when you click OK it will pop up here in the MAX. So now here I have one real device called dev1, and then I have a simulated device called dev2. And then you can change the name for it, etc. and you can use it as a replacement for a real device when programming your code in our case in Visual Studio and in C#. So next let's see how we can use this DAQ device in Visual Studio and in C#. So we start with an analog in example, and then I will just demonstrate a simple example I have called battery indicator example. The application looks like this, a simple application where I have a text field, a button, and just a label. So basically when I click on this read button, I'm going to read the current value from the analog input channel where I have connected a battery. And then as you see in this example, when I click read, I'm able to read the current voltage value from this 1.5 voltage battery. So here you see the wiring. Here I have a battery, a 1.5 voltage battery. I have two wires connected to the battery, one plus and one minus. And the red one plus goes to the DAQ device, to one of the analog input channels. So this is the analog input channels number 0, and the plus is the red cable. It goes to plus on the battery, and minus on the analog input channel 0. The black cable goes to the minus pole on the battery, like this. And then you just plug in and connect the DAQ device to your computer using this USB cable. So then you need to start up your Visual Studio, and then the first thing you need to do is to select the proper template. So make sure to select the Windows Forms App .NET Framework template. This is because so far NI-DAQmx is not supporting the newer .NET 5 or higher, so you need to use this Windows Forms App template and the .NET Framework template. So you need to use this template and not this template. Next, you need to select or create a proper name for your project. In this case, I just call it a battery indicator, and then I select a proper location on my hard drive, and then I select the newest .NET Framework version, in this case .NET Framework 4.8. Next, we need to add the proper reference in order to communicate and use the DAQ device. So the reference that you need to add is this national instruments.DAQmx.dll. So you basically go in your Solution Explorer and click Add a Reference, and then select Browse, and then typically the DLL file is installed in this location. So then just make sure to select this DLL and click OK, and then you have added the necessary reference in order to communicate with the DAQ device. And then next you are ready to start creating the necessary code, and here you see the main code structure in order to be able to read an analog input value from the DAQ device. So first you need to, after you have added the reference to the DAQmx DLL, you need to use using national instruments.DAQmx on top of your code, and then you need to start creating a task. So you need to start by creating a task like this, and then you just name it. In this case, since it's an analog input task, we just name it analog in task. And then you need to specify or create a channel, and since we are reading an analog input signal, we need to create an analog input channel, and then you just name it my analog input channel or whatever. And then you need to specify the properties for that specific channel by using the name that you have created, equal analog in task dot AI channels dot create voltage channel. Here you have different options, but we are basically reading a voltage value from this battery that we are connected to the DAQ device. So then we select create voltage channel, and then we need to specify some properties. Dev1 is the name of the device. This can be changed in the Max software, which I've shown previously. And here you specify the channel that we're going to use. I have connected my battery to the analog input channel number 0. and here is just the name of the channel, which I have specified here. And then next we need to specify if we have connected or used a differential configuration or a reference single-ended. In this case we have used a differential configuration, meaning we have a separate ground for each of the channel. So as you see here on the wiring, so since we have used plus here and minus here, we have connected this analog input channel as differential, because each channel, this is analog input 0, here analog input 1, analog input 2, etc. Each of those has a separate ground wiring like this. So the red goes to the plus connector on the battery, and then minus, and the black one goes to the minus connector on the battery. Next we need to specify the voltage range. I have just specified from 0 to 5 voltage, since this is a 1.5 voltage battery. And then I need to specify the unit, and in this case it should be volts. So basically that's the properties that we need to set, and then we are now almost ready to be able to read data from this analog input channel. So the next we need to specify an analog single channel reader, just like this, and then we can use the method read single sample in order to be able to read one sample from this analog input channel. So basically this is the entire code that you need to create in order to start communication with the DAQ device and read a voltage value from this analog input 0 channel on this DAQ device. So now I have opened my Visual Studio, and here you see the graphical user interface. I have a text box which I have named TXT battery level here in the properties window. I have a button with the name read, and the name of the button is button get data, and then I have just a label here on top, and then I have just double clicked on the button in order to create the necessary code in order to communicate with the DAQ device inside this button click handler. And also, as mentioned, we need to go to reference here in order to add the proper national instruments.DAQmx DLL. So when you just select this one, it will be shown here in under the reference folder. And also the next step will be to use this using national instruments.DAQmx here on top, and then we just need to create the code that I explained. So first we need to create a task, in this case an analog input task, and then we need to specify an analog input channel, and then we need to specify the properties for that specific analog input channel, and we need to specify the device name, which is dev1, which you find here in the Max. So let's just open the Max software and just type Max, and then this measurement and automation explorer will pop up. So as you see here under devices and interfaces, connected this USB 6008 with the name dev1. You can of course change it here, but I just leave the default name, and then I need to specify the name here, and then I need to specify the channel analog input 0 and the channel name, which I have specified here. And as mentioned, we need in this example to specify differential terminal configuration, and then the voltage range, in this case just from 0 to 5 voltage, and then the units is in voltage. And then we need to specify or create an analog single channel reader, because we are only going to read one value from this analog input channel. And then we just use the method which is part of the reader. So reader.read single sample is the name of the method. And then we can just create a variable called battery level or something, which is of type double. And then we have this text box, which is defined here. Text battery level dot text equals to this variable battery level, and then I need to convert it to a string, since this is a double and the text box is a string. So then I just use toString and specify with 2 decimals like this. So basically that's it. So then I can just click the start button, and then we have the application here. I can click on the read button, and then you see I'm able to read the current voltage value from the connected battery like this. So basically this is how we create a basic analog input example using Visual Studio and C#. In the next example I will show how you can read data from a temp36 temperature sensor. This example also using an analog input channel. So it's very similar to the previous example, this battery indicator example, but instead of a battery, we use a temp36 temperature sensor. So here you see the application for this example, the temp36 temperature sensor example. So it's very similar as the previous example. We have a text box and we have a button that we click on in order to read a value from the DAQ device, and in this case we are converting the voltage value we are reading into a value in degrees Celsius, but the user interface is almost identical, and also the code is almost identical. So here you see the temp36 temperature sensor that we are going to connect to the DAQ device. It's a very small and simple to use temperature sensor, and it's also quite cheap. It costs $1 or $2 or something, and you can buy it almost everywhere. So here you see the wiring diagram for this temp36 temperature sensor here. This is temp36 temperature sensor, and it has 3 legs. One legs go to the ground. One leg goes to the 5 voltage output of the USB 6008. And the third leg, the leg in the middle, is the analog signal, and it goes to one of the analog input channels on the USB device, the DAQ device. I just use the first or the 0 analog input channel. And compared to the previous example, the battery indicator example, here I have used reference single wiring. So in the previous example we used both analog input 0 plus and minus. Plus was on the positive battery pole, and minus here was on the negative battery pole. But in this example we are only using the analog input 0 plus connector. Since in this case we are using reference single-ended, this means that all the analog input channels has a common ground, which we connect here on the right side of the DAQ device. So either you can use the ground here, or you can use this ground, this ground, this ground, or this ground. But since we already used the 5 voltage output here, I've chosen to use this ground pin in this wiring diagram. So this is the wiring diagram. Here you see the physical connections. So here you have the ground, the black wire goes to the right pin on the temp36, and then 5 voltage go to the left pin on the temp36, and then we have the middle pin that goes to this analog input channel, analog input 0. And this wiring is so-called reference single-ended. So from the DAQ device, here we read a voltage value, but typically we want to have the value in degrees Celsius, since this is a temperature sensor. So from the data sheet, so just search for the temp 36 data sheet, and then you will find this figure inside the data sheet, and based on that figure we can find the relationship between the voltage value that is coming from this middle pin or this pin, and so the relationship between this voltage value and the temperature in degrees Celsius. So then we have a temp 36, and this is B, so it's this curve, and this curve indicates that it is a linear relationship between the voltage value and the temperature in degrees Celsius. And then from this figure we can find the following formula, which gives the relationship between X in this case is the voltage value and Y is the temperature in degrees Celsius. So we need to use this formula in our application in order to convert from the voltage value we get from the DAQ device in order to calculate the temperature in degrees Celsius. So here you see the important part of the code. Here I have just created a simple method called read temperature. I will show the entire code later, but I just go through the basics. The code structure is the same as in the previous analog input example, where we use this battery as an example. So first we need to create an analog in task, and then an analog input channel, and then in the analog input channels we can use this create voltage channel method and set the different properties for this specific channel. So this is the device number, device 1, which you can change in the max. Here is the channel number, analog input 0. Here, as mentioned, we are not using no differential, but we are using reference single-ended. And here is the voltage range from 0 to 5, and here is the units in voltage. And then we need to create a reader, and then when we have created the reader we can use the read single sample method in order to read the voltage value from the DAQ device, and then we're using this basic formula in order to convert from voltage value to a value in degrees Celsius. So basically that's the important part of the code. So let's go to Visual Studio and see this application in action. So now we are back in Visual Studio, and now I have wired my temp 36 temperature sensor on a breadboard and connected it on the analog input channel 0 using reference single-ended on the DAQ device, and I have plugged in the USB cable into my computer, and I have created a graphical user interface, basically text box where I will present the temperature in degrees Celsius. So this is just a label, this is a text box, and then I have the button, and when we click on the button this should be filled out with the proper temperature. So if you just double click on the read button, so when you click on the read button this code will be executed. So basically inside this event handler for the button I just call this read temperature method, which I have created here. So basically this one initialize the DAQ device and reading one single sample from the DAQ device using this read single sample method, and then I get the value in voltage, and then I convert the voltage value to a temperature in degrees Celsius, and then this method returns the temperature value which we get here, and then I just convert this temperature value, which is a double value, and convert it to string so I can put it into this text box. So that's the entire code, and of course we need to add the proper reference, this national instruments.DAQmx.dll, which you just click here on add reference, browse for this reference and select it, national instruments.DAQmx. Typically it's located here as you see, under Program Files, National Instruments, Measurement Studio, etc. So just go to this location in order to find the DLL and just select it and click OK, and then the reference will be here in the Solution Explorer here, and then we have included the necessary reference. You need to include the name space here, National Instruments.DAQmx. So that's the entire code. This is the event handler for the button, and this is a separate method created for reading one value from the DAQ device and convert it to a value in degrees Celsius. So then go to the user interface. We click on the start button, and now I can just click the read button, and then the value here are in the temperature value in degrees Celsius. When I now hold on the button with my fingertips and click the read button, you see the value is increasing. So now I'm still holding on the fingertips on my temperature sensor. Then I can release it, and then you will see that the temperature is falling like this. Now I can hold my fingertips on the temperature sensor again, and then you see it will increase. So basically, this is how you read a voltage value from a DAQ device, and then in this case we just convert the voltage value to a temperature value in degrees Celsius using this DAQ device from NI, this USB 6008 or similar, and in this case we have used this temp36 temperature sensor. So the next example that I will present is an analog out example. Here you see the graphical user interface created with Visual Studio and C#. It's very similar to previous examples. You have a text box, but in this case I don't have a read button but a write button. So when I specify a value here between 0 and 5 voltage and click the write button, I will send this voltage value to the DAQ device, and then I can, as you see here, I can connect. So here I have connected and use the analog output channel number 0. So this DAQ device has two analog output channels. So this is analog output channel number 0, and these two are analog output channel number 1. Here I have used analog output 0. So basically here is a spelling mistake. So this is analog output channel number 0. So these two connectors are analog output 0, and these two connectors are analog output channel number 1. And then the black wiring is the ground that I can connect to the ground connector or the connector on a multimeter, and then the red one is the positive pole which I can connect to the other input here on the multimeter. So when I enter 3 here now, click write, then I should see the same voltage value here on the multimeter. Here you see the most important part of the code. It's very similar to the previous examples. We need to add the reference and then using National Instruments.DAQmx, and then here is the basic code for writing a value to an analog output channel. So then we start by creating an analog output task and an analog output channel, and then we need to specify the properties for that analog output channel. And then this is the name of the device. Here we specify the channel analog output 0. Here is the name of the channel that we specified here. Here is the voltage range from 0 to 5, and then the units. And then instead of our reader, we need to create a writer, since we now are going to write a value to the DAQ device. And then we basically just use, since here we are going to enter this value in the text box, so we need to convert this value from the text box to a double value and put it into a variable. I have called the variable analog data out. It's a double, while the text box we have here is of course a text value, so we need to convert it to a double. And then I can just use the built-in method in the writer object that is called write single sample. And then we just specify the voltage value here, which is this value that we specify in the text box. So let's go to Visual Studio and see this example in action. So here is the graphical user interface. It's a text box where when I start the application, specify a value between 0 and 5 voltage and then click write in order to write this specific value to the DAQ device. And here you see the code. Of course, I have the necessary National Instruments.DAQmx reference. I'm using the namespace here. And then inside this write event handler, I have created the code. Of course, you can create a separate function, etc., in order to improve the code and the code structure. But for simplicity, I have just created everything in this write analog data event handler, which is the event handler for this button. And then we just specify an analog output task, an analog output channel, and then we specify the properties for that specific channel, device name, the channel name, voltage range, unit, and then finally we just use this write single sample in order to output the analog value to the DAQ device. So let's just run this example. Now this is the graphical user interface, and then I can just specify, let's say, 3 voltage here. When I click write, I see here on my multimeter 3 voltage. When I change it to 2, click write, and then I see 2 voltage on my multimeter. So basically this is how we use the analog output channel on the DAQ device in Visual Studio and in C#. So here you see the analog output example. So then I just specify a voltage value here, let's say 3 voltage. I click on the write button, and then let's go to my multimeter, and then here you see the wiring. This is analog output channel number 0, which is connected to the multimeter, and then you see on the multimeter display you see 3 voltage. And let's change it to 2 voltage. Click on the right button and then go to the multimeter, and then you see the multimeter now shows 2 voltages. Basically this is how the analog output example is working. So the next example is a basic LED example. Here we will use the digital channels, in this case digital output. So basically in this example we will connect or wire a LED on the breadboard, and then connect the LED to the digital output channel on the DAQ device. And then here you see the basic graphical user interface. This is just a checkbox. So when you check this box, the LED should turn on. When we remove or uncheck it, the LED should turn off. So here you see the wiring. We need a basic LED. Here we have a breadboard, and here we need a resistor. It could be 270 ohm, it could be 330 ohm or similar. We just using this resistor in order to limit the current that are flowing through the circuit. If the current becomes too high, the LED will be destroyed. So basically just use any kind of resistor in this example. So then we wire here on the, this is the, the digital channels. Here we have here on the right side of the DAQ device. So this is digital channel number 0, and then we can specify different ports. So this is so basically we have P is for port, so then we have a digital port 0, and then we have channel 0, 1, 2, 3, etc. And then here we have digital port number 1, channel 0, 1, 2, 3, etc. So we can control all these digital channels to be either input or output, and we can also turn on either one at a time or turn off one at a time, or we can control multiple channels in one operation. So here we only need to use one digital channel, and it has to be a digital output channel. So that's something we specify in our application, if it should be a digital input channel or a digital output channel. And here you see the physical wiring. Here you have the breadboard, the LED, the resistor, and the DAQ device. And here we have the digital channels. This one is ground. So this one is connected to ground, the black wire, while the red one is connected to the first port on this first channel here, namely port 0, channel 0, which is the first connector here. And here you see the basic code example, the main part of the code. I have just created a separate method called LED light, and the input to this method is a boolean, either true or false, according to my graphical user interface. So when then the checkbox is selected, this value will be true. When it's unselected, it will be false. So when it's checked, meaning true, then this LED should turn on, while it's unselected, it should be false, and this LED should turn off. And here it's very similar as previous examples, but here we need to create a digital output task. And then when we have created the digital output task, we need to create a digital output channel and then specify device name, which is set in the Max software, port, either port 0 or port 1, and then line. In this case we just use the first line 0 or channel 0 in this case. So this is the specification of which connector we are going to use on the DAQ device. Here is the name of the channel. Sorry, this name is not so important here, but for next one, channel line grouping, here we need to select in this case one channel for each line, because we have line 0, 1, 2, etc., and then we just specify for that each of those lines should be a separate channel. And then we need to create a digital single channel writer like this. And then when we have created the writer object, we can use the method which is part of this object, write single sample single line. And then you have this LED, which is the input to this function, and this one should be either true or false. If it's true, the LED should turn on if you have wired the LED correctly on the breadboard. If this variable LED is false, the LED should turn off. So let's go to Visual Studio and see this application in action. So here we are in Visual Studio. Here we have the basic graphical user interface with just a checkbox, which you find here, the checkbox. So this is either true or false. And then I just double click on this one, and then we go to the event handler for this checkbox. And inside here, I just specify a variable called LED. In the beginning, I just set it to false. And when this checkbox is checked, I set this variable to true. When it's unchecked, I set this LED variable to false. And then I just call this method called LED light, which I have created here. And here is all the code for communicating with the DAQ device and turn this digital channel either on or off. So we start with creating a digital output task, and then we need to create a digital output channel, and then we specify this information and this channel line grouping, and then we need to create this digital single channel writer, And then in the writer object, we just use this write single sample single line method, which we set either to be true or false using this Boolean variable. So let's just run the application. So now this simple on my breadboard I have this LED, and now it's turned off. When I click here, my LED will be turned on, off, etc. So basically this is a simple example how you can use the digital output channel on the DAQ device. So here you see the digital output example here on the DAQ device. I have used this first digital pin, which is the red one, and here the black one is connected to ground, and here you see the wiring for the LED. This is the LED and this is the resistor, and here you see the application. So now this one is unselected, and then you see the LED is off. When I click on this one, then you see the LED has been turned off. Now I unselect it, and then you see the LED is turned off. So basically this is a simple digital output example using this basic LED. So now I will present the final example. This is a push button example, and this will be a digital input example. So here you see the application in this example, the push button example. So basically it's very similar to previous example, but now when we click on the push button that is put on the breadboard, then this should be selected, and when we are not pushing or clicking on the button, this should be not selected. And here you see a basic push button, and here you see the wiring for this example. So we use the same channel, but now we specify that this channel should be on digital input channel. So here you see the push button, and here we use also something called a pull-up resistor. I will try to explain why we are using a pull-up resistor later, but first just go through the basics here in this wiring. So here we connect 5 voltage, and then it goes through this pull-up resistor, and then when we click on the push button, it should flow current through this device, and then it should go back to the ground, and then we can wire here between the resistor and the input to the push button to the digital input channel on the DAQ device. Here you see the physical wiring, where we have the DAQ device and the breadboard. We have the push button here. We have the 10K resistor here, which is this external pull-up resistor, and then we have wired it, the red one to 5 voltage, the black one to ground, and this orange one to the digital input pin or channel here on the DAQ device. Here you see how this circuit will function and why we are using this pull-up resistor here. In this case, to the left, here the button is not pushed. This illustrates the button. So when the button is not pushed, there will flow no current through here, and then all the current will flow from 5 voltage to the digital input pin. And then in this case, we will get a high voltage on the digital input pin, and this means the value is what you call true or high in Boolean terms. So in digital pins it can only be 2 values, either true or false. So in this case we read 5 voltage, meaning that the digital pin is set to true or high. But when we push the button, you see this switch or button or the circuit will be closed here, and then all current will flow from the ground here or to this digital input pin. There will be flowing no current here, only here. This means that in this case we will read a false value or a low value here on the digital input pin. So when the switch or button is open, we will read 5 voltage. When the push button is pushed, we will read 0 voltage in this case. So let's go to Visual Studio and see this example in action. So here you see the basic graphical user interface that have been created with Visual Studio. It's just a basic checkbox and a name, push button status, and when we push or click on the push button, this should be selected. When we are not clicking on the push button, this should be not selected. Let's go to the code. And one thing more, I have in this case also created a timer. This means I'm reading from the digital input channel, in this case every 100 milliseconds. So every 100 milliseconds I'm reading the latest and updated value that are on this digital input channel. And then here in the timer tick, here I check this checkbox either to be true or false based on what I'm reading from the DAQ device. And I have here created a method called read push button, which you find here. And basically inside this read push button you find all code for communicating with the DAQ device and read a single value from this digital input channel. So here I start by creating a digital input task. Here I create a digital input channel. I specify device name, port 0 and line 0 in this case, and then channel line grouping is one channel for each line. And then I create a reader in this case, since I'm going to read from the analog input channel. And then when the reader object is created, I can just use the built-in function called read single sample single line, and the output of this function will be either true or false. So then the return value will be just a boolean value I have called push button, which is either true or false. And then I return this value here back to the place where I have using this method, and then based on that I either check or uncheck this checkbox. So let's just run this application. So now the checkbox is unchecked. So now I can click physically on the push button I have here on my desk here. So now I'm clicking on the button. You see this has been selected. Now I'm releasing the push button, and then you see this has been unselected. Now I'm pushing the button once more, and then you see it becomes true. Now I'm removing my hand or finger from the push button, and then you see it becomes false. So basically this is basic example how you can use a push button on the digital input channel on the DAQ device. So that's all. So good luck using Visual Studio and C# in combination with your DAQ device. Thank you and goodbye.